Hi, and welcome to this video on forces and force diagrams. So I'm going to be filling out this sheet and then going through and filling out this table as we do it, or maybe we can do that at the end. So the first question is, what is a force? And I'm going to just give you, or actually I was going to say in class, if we ask the question, what is a force? We might get a lot of answers. We might, someone could say, talk about, say, Star Wars, use the force. There's lots of different ideas about what force is. I'm going to give you a definition here. I'm going to say a force is two things. First thing is it's an interaction between two objects. And the second part is that looks like and this is the second part, looks like a push or a pull. So whenever you see something that is pushing or pulling, whenever you see something that might be a force, it's important to kind of look and ask yourself, what are the two objects that are interacting, that are pushing or pulling? So I'm going to go through some types of forces, and we're going to look at each of these questions, and we're going to ask whether or not it's a contact or a non-contact force. We're going to ask ourselves, what's the direction, or how can you figure out the direction of the force? When is this force present? What symbol should we use? And the equation. In fact, we won't figure out the equations now because you will be figuring them out while in class. So the first one is a gravitational force. Usually when I say, hey, what's a force acting on me, or something like that. So here I am, and I'm on the ground here. I'll give it some arms. You can say, what are all the forces acting on me? And the first one that people say is there's a force of gravity that's acting on you. Now, do I need to be touching the earth to be have this force? Like, if I'm in the air over here, I'm happy because I'm in the air. Is there also a force of gravity acting on me? Sure, there is. So I could say here there is a force of gravity. We're going to go a capital F with a subscript G. Even when I'm up in the air, there's also a force of gravity acting on me. So I'm going to go back to the sheet back over here, and I'm going to fill this first one in, and I'm going to say the type of the force that we have here, I'm going to call it gravity. For the direction, we can just say down. Or I guess better we could say, towards whatever planet you are on. When is it present? So gravity is going to be present when close to a planet. Or really you could say when you're close to another large mass or large mass. That's when we're going to notice gravity. What symbol are we using? We're using F. We're going to use F for all the forces, and then the subscript will be G. The equation we're going to do later. And I really should have had another part in this table. Up off to the side, we're going to say, is it a contact force or is it a non-contact force? In other words, do the objects need to be touching? And in fact, what are the objects? In fact, let's just go back over here so that we can write it in. So when I'm close to the Earth here, what are the two objects that are interacting? So it's going to be the force of gravity. And I'm going to have us write these on-by statements. So in this case, I'm going to say on, well, this diagram, it's me. So I'm going to say on me by Earth. So when I write this arrow here, that arrow there, the green one, when I represent that arrow, I'm going to say that is the force of gravity acting on me by the Earth. Okay, so going back to over here, the previous page, is it a contact force or non-contact force? It is a non-contact force because me and Earth don't need to be touching. Back down to the other page, talking about the normal or perpendicular force. First of all, I want to mention that the word normal actually means perpendicular. So what's perpendicular? Well, in math, you can see this every once in a while. That symbol there, that would be what perpendicular looks like. It's two lines that form right angles with it. So whenever there is a one surface pushing on another surface, there's going to be a perpendicular. So here's an example here of a book. So if I just draw a diagram for a book that's, say, on a table, I'm going to say, okay, well, there's a couple forces acting on that. First of all, we know that there is, and I'm going to represent that book with just a dot. We know that there's a force of gravity acting downwards because it's, close to the Earth. But there's a table in the way. This table is pushing back upwards on that book. Here's the table a little bit better. So the force of the table pushing up on it. Well, if we zoomed in on that table and we looked at this surface here, just like this surface here, the direction of the force of the table on the book is going to be perpendicular to the surface. Perpendicular or normal. So this force upwards is the force of the table pushing up. So I'm going to say this force of gravity is on the book by the Earth. And this normal force or perpendicular force is on the book by the table. It might be hard for us to, in the idea that the table is pushing back up on it. So here's a picture just to kind of show it as well. If we had a spring and we pushed down on it, we could see that the spring was compressed, and so that it's easy to see in this case that this spring would be pushing upwards. So in this diagram, we'd have a force of gravity downwards, and we'd have a normal force of a spring pushing back up again. If we zoom in on the particles of the table, and if we could get down to the particle level, we would see that the table actually does spring, like it does compress a little bit, and it does push up on the book or on our hand. The other thing I want to mention is that you got to be careful about the surface. Here we had a table that was horizontal, so the normal force was straight upwards. If our table was at an angle, so if we had this table this way and we put a book on here, we would have, this would be the direction of the normal force, because this is a right angle. So remember that the normal force means perpendicular force, and it's at right angles to whatever surface. Okay, I'll just fill these in first, and then we'll do the chart at the end. The other one is a friction or a parallel force. Okay, so again, if I put this say a box or something on a table, and let's say if I push it along, so it's moving this direction. So let's say it's moving to the right. There will be this table and the box are kind of interacting, and again there will be a normal force that's pushing upwards on it. I'm going to say the normal force on, say, box by table. But if this box is moving to the right, I'm putting V for velocity, so imagine it's moving to the right. So if we did a diagram, say it's moving this way, say there's our motion map, there's going to be some friction on it. There's going to be some friction that's going to be pushing it the other way. It's going to be trying to slow it down. So again, it's a contact force between these two, and the friction force, if it's moving to the right, the friction force is going to be to the left. Friction force on box by the table. Of course, this one as well, there would be a force of gravity acting on the box by the Earth. So there's an example of a friction force. So the friction force and the normal force often appear together. And the normal force, so if there's one object that's pushing on another, the contact force there'll be a normal force which is perpendicular, and there'll be a friction force which is parallel. So in this case, you can see that here's the surface and here's the direction of the friction. So those two lines are parallel. In the normal force, the two lines are perpendicular. And another thing to mention about the friction, it happens with a moving objects, and also when there's two objects, and let's say there's this one here, and I'm pushing on it a little bit, but it doesn't move. So you can also have objects that sort of have a tendency or want to move. Objects that might move if there was no friction. So you can have it, we kind of have two flavors here. I'm going to call this one kinetic friction. And the ones in a situation where if I'm pushing on the object but it's still not moving, we're going to call that static friction. And we'll be talking more about that later. Okay, so moving on to the next page. We can have something that we call an applied force. So really, most of the time, if our finger or our hand or ourselves, if we're pushing on something, so it's like an outside person or object is pushing or pulling. So let's go back to the box, and again, I can't draw very well, but let's say here's my finger and I'm pushing on this. We just can call that an applied force, and usually the symbol we do that is FA for applied. Really, it's the same thing as it's a kind of a normal force, because we have one surface, the edge of my finger pushing on the box, but we like to talk about the applied force, and I know that the physicsclassroom.com kind of concept builder that I want you to do uses applied, so I wanted to mention it. The last one, the tension force, is whenever we have or not the last one, but the second last one, when we have a string or a rope, that would be a tension force. So here's an example. Let's say if we have an object on a string attached, then we would have a tension force. Now, which way would that string be pushing or pulling on the object? That string would be pushing or pulling upwards. So we could say that the force of tension would be upwards. We can also, have a horizontal rope or a string that's pulling on the object sideways. So it can be in different directions. The last one we have here is a spring. So I don't know, I'll do an object here. So here's a spring like this, and we put an object on the top of it. Which way is the spring pushing or pulling? In our case here, the spring would be pushing upwards on that object. So if you look at that object, it would be pushing upwards on it. So the force of the spring would be upwards. We could also do a situation where if you had a spring that kind of looked like this much, and if that's how it normally was, and we made the spring, we stretched it out, the force could actually be to go back to its original shape. So the force of the spring is whichever direction that it needs to get back to its normal equilibrium. That's the direction of the force. Okay, so let's go back to that chart and fill those out. So if we're back at the chart, now the second one we did was a normal force. And remember, the normal force, another word for normal is perpendicular. Perpendicular, which kind of means this way. So the direction will always be perpendicular to the contact between objects. Perpendicular to contact. So if there's two objects, here's another example. Let's say that this small object is pushing on the big one. So, here's the surface of contact, so it's going to be perpendicular to the surface. Actually, I'm going to write that perpendicular to surface. And it is a contact force, because things have to be touching for it to happen. When is it present? Well, I would say when objects touch. And there's got to be a little bit of, I tried to mention it before, there's usually some compression, and some compression happens. So with the old box on a table idea, we may not see the fact that this table is getting a little bit compressed, but the particles of the table, if we got really down to it, the particles are being compressed, and they're pushing back. Okay, you can think of that. So the symbol that we use for normal force, F, I usually use a capital N for normal, but it doesn't really matter too much. I notice that's my habit. And again, we're not going to worry about an equation for now. The next one that we covered was the friction. And the direction for this one is going to be parallel to the surfaces that are in contact. So parallel means, like, there's the symbol for parallel. When is it present? So when the objects are touching, and there's some, so not compression like up and down, but rather when there's some sideways shearing takes place. When there is some sideways So if I got this box, I'm gonna kind of make it look like this a little bit. So if I push on that one and it makes this kind of get distorted, like if you imagine a box and you're pushing it, looking at the surface between here and the box and looking at the way these particles are interact, when the box is going to cause these particles here to get pushed over a little bit. So whenever there's I guess another way to say it, some sideways shearing or sliding can take place. So whenever there's either a motion between two surfaces, or when there's, when we tried to push it but friction opposes it, the symbol that we do is FF. The equation we'll find out later. The next one we did was applied force. The direction, it's usually stated. Now applied force is, we say, okay, so if we have an applied force, if you push on it, or if we create a force, so it's usually stated, usually given. And remember, applied force is kind of like a type of a normal force, because if we're going to say we're pushing this, when is it present? When outside object either pushes or pulls. We'll do some examples and you'll see these ones. The symbol that we usually use for this is FA for applied. And I don't think there's going to be a formula for this because it's just going to be stated. Here is an applied force. Go back over here. This is a contact. Friction, there's got to be contact because of the surfaces. For applied, it's a contact force because there's some object that's pushing on it. The next one was tension. And again, the tension is when there's a rope or a string that's pushing or pulling. I guess got to pull. You can't really have a string that pushes. That's a contact force because the string has to be touching it. What would be the direction? The direction that a string or a rope pulls would be the same as the direction of the string. So you could just see that with the direction of the string. So if I had, if I had this, then the direction of the force would be the same as the direction of the string. When is it present? Well, look for a string. When a string or rope pulls. We call this one a tension force, Ft. Every once in a while you'll see places just do a T by itself for tension, but I'm going to try to use the capital F with a subscript T. So just for a note, you might see in other places like physicsclassroom.com that you just use a capital T. The last one we have here is a spring. And the direction, well, whatever direction returns the spring back to its original shape. So we can say that the spring pushes or pulls to return to original shape. And that kind of describes both the direction and when it happens. When you have a spring that's either been compressed or stretched. Spring is compressed. Compressed means get smaller, or stretched. So if you have a spring that's stretched or compressed, it's going to try to get back to its original shape. I think you can probably guess the symbol is capital F with a small s, and we don't have an equation yet, and it is a contact force. So at the bottom of the sheet, I have a kind of way of building a sentence. And this part is either contact or non-contact. And here would be the name of the force. Okay, so object, this would be an object here, exerts on the object. Newton's first law and Newton's second law, that's going to be a bit later on. We're going to get to that. So just to return to our page, if I do an example, let's say, my first example of me happily, falling down towards the earth, I'll have one force acting on me. I'll have this force of gravity. And I always like to have the on and by notation, so it'd be force of gravity on me by the earth. So this is what I mean by having an on-by notation, force of gravity on me by earth. Or I could ask you to say, hey, what's a full force sentence? So if I ask you to do a force sentence, then it would be, this big one over here. Let's do the force sentence for this example. So we could say is it contact or non-contact? The non-contact gravity, or you could say gravitational, but gravity is okay. The non-contact gravitational force the Earth exerts on the, I'll get rid of the on me. That would be the force sentence version. I would really recommend taking a look at this short video too, and especially if you're taking chemistry, that talks about all the contact forces at the particle, at the molecular level, done by, I think the guy's name is Bozeman, and he's got a great chemistry background, and I think he made that video for someone taking advanced placement physics. It's nice and short. I'd also like to mention that there's a very good resource called, there's a reading coming, just a couple more pages, that talks about the same things that we've been talking about. There's a few more forces that they mention. So they mentioned the normal force, and it's a push or a pull. They mentioned the tension force. They mentioned the gravitational force. But you'll notice that they have a few other ones too. They have the electric or magnetic forces that we won't really be dealing with until we're next year in grade 12. Also, when we have, say, an airplane, I'll try to draw my airplane here. If we have an airplane going through air, clearly we're going to have a force of gravity downwards. The upwards force we would call, and it's because of the way that the air goes over the wings, we're going to have a force called lift. The forwards force, that the engine is pushing it forward, or actually that we'll get to it later, the details of it, but this forward force is, they often call thrust. And the backwards one here is going to be drag. So these are just some common ways of describing the forces. We could use, we don't have to use these ones, but I just wanted to mention it. So this is a good one to read through, and as just a bit of a reference. So I think the video's been long enough, so I'll stop now, and I will see you in class.